into the hands of an animator who wasn't at the shoot all the retargeting work, and they're not getting it right. And that just adds all these speed bumps or potential roadblocks. So we're seeing a lot of that frustration. It's real frustration, but a lot of us, after 20 years in the industry, have kind of accepted that as, well, that's just kind of like how that is. That's just kind of what that's the job. That's what our job is to negotiate that space. And we maintain that there are things, for instance, the Qualisys can do that actually other teams have not, and how that might make a difference. So if we can do the next slide. And so I've already just talked about that. Studios feel they're left, frankly, with just a vendor and not a partner. We've based that 35 years of pedigree on being actual partners. We show up, but we don't leave, unless you ask us nicely to go away. But we show up and you don't leave, and so you're not left with, well, it landed on the loading dock, I put it up on the box truss, now it's up to us to solve the problem. Maybe we can get some licensing support or some scripting stuff done, but it's very much a vendor relationship, it's not a partnership. And we've built all of our relationships on that partner method. And that makes people feel a lot more supported and a lot more that they can go forward with confidence rather than, I guess we got to figure this out on our own. Or you end up having to pit companies against other companies to get the result you want, right? We feel that that's not necessarily how we want to approach the market. So, yeah, stop it for just a moment. So essentially, I've talked about the pedigree. We're familiar with a lot of what we've done has been so diverse, we feel we can basically go into any situation and help solve. We don't think we are the choice for a small studio that wants to do 10 to 12 cameras and I'm capturing a person, no props. That's not us. That's not what we think our strength is. What our strength is that usually focusing on like the larger volume that has its own laws of thermodynamics that need to be overcome, or custom situations that no one has ever encountered before, but you're going to be countering new situations, whether it's theatrical, whether it's very large volumes, or even just complex problems that out of the box we're not going to solve. That's where we think our strength is. So we don't think we've got the Swiss Army knife for every single solution. We think that's foolish. We lean on our strengths, and we want to kind of share that with you today. First and foremost, again, I want to kind of engender this whole openness. Any questions around anything that I've said thus far? I want to make sure that everybody here understands that what we're doing is not on the rails presentation. It's very much, if you go, oh, I have a question, we really want you to throw your hand up and go, why? Or haven't you thought about that? Or we've done this, what do you have to say about that problem in regards to that question? Please, I want to encourage that kind of discussion. So the next video here is essentially, it's a wonderful case study and marketing thing from Beyond Capture. We're going to hear from Graham Qualley later on. It just kind of shows what I'm talking about solving big challenges and how we were able to meet the challenge. So if you can hit the play button.
Sorry, you want to pause for a second? I'll fix this.
It's a very intimate volume setting. More for a drawing room than a mocap stage.
Buried 40 levels deep.
Yeah. Why would you need an audio?
Great UI design.
Yes. Yeah, volume's in there.
No, I'm trying to get the system over.
Oh, okay.
I accidentally did that.
I don't know how that.
This one.
Oh, right, okay, yeah, okay.
each met with the major brands in a head-to-head-to-head test, and it wasn't even close. Qualisys was the only one that not only met what we needed, but exceeded it. At gun capture, one of the biggest challenges is the size of our stage. Qualisys cameras were the only ones that could capture it.
We can really go back and forth from being very intense with a lot going on to the quieter moments that are really important to catch. There's a lot of creative liberty and space for exploration and experimentation.
The culture of Qualisys to have a symbiotic relationship to make things better for us, to make things better for them, has really improved what we can offer our clients.
Got some of the brightest mocap minds in the world right here. It's a full potential to create and explore, which has just been fantastic.
A great team, the best hardware, and the best people to get the most out of that hardware. With Qualisys, the sky's the limit.
Woo! Yay. Thanks for the audio-visual help. So, I mean, that's one example. But we've basically taken the approach, like I said, that we just need to basically be put into the environment to understand the situation. And if optical can solve the problem, we're confident we can basically be the people who can provide that solution. So that being said, what we're going to do is we're going to get under the hood here and talk about the optical cameras, QTM real-time tools, and then our engine integrations that we've kind of put together. And so what I think we're going to do at this point is, I think what's really interesting is to talk about the hardware itself. And I'm going to kind of lean on Jake a little bit to kind of answer questions around so we've got a number of different cameras here in the volume. What's interesting, the thing that always, because I ran a motion capture stage, and cabling was always my biggest nightmare, especially if I had to move the cameras and deal with something, especially when each camera had to get its own cable. What you can't see right now easily, which breaks my heart, is that each of these cameras, and we have 20 up right now, are daisy chained. So there's one cable going from camera to camera to camera, all the way in one unbroken chain, in one loop. And then all these cameras basically are going into the QTM laptop via one network cable. So there's no switches, there's no hubs, there's none of that. So in contrast, there's another camera company who has their cameras up in here, and they're lovely people, but you'll notice that the majority of these cables are not ours. Only one of them is, as you go around the room. And from ease of use and diagnosis, or even expansion or contraction of your volume, this makes it incredibly easy to admin your hardware. You don't have to be an IT supervisor or manager to do load balancing on the switches or the hubs. You just basically make sure that you have working cables, because we do power and network over one cable. And they're custom cables, but it's effective because it means I'm no longer having to worry about that as overhead, just operationally. And there's already enough on a mocap stage to think about. The other thing that we really, and to go along with that, that means that every single camera is powered, the Arcus cameras are powered by one power brick every 5. We have smaller cameras called Micas, which are powered like 10 cameras every power brick, and you plug it in. But that means that you basically have the ability to unplug, add cameras, plug back in, and as long as you have the power bricks, you're ready to rock and roll, and there's no challenge there. The power means that our systems are powered correctly for the distance you're trying to reach towards. So one of the biggest challenges, especially along longer distances or larger volumes, is that if you don't have enough power going to your LED rings, then you're going to get intermittent results as you go farther out towards and from that sensor. And welcome, welcome. Come in if you want to sit down. And I appreciate for almost nobody wearing the naughty sneakers.
Oh, the Nike ones?
Yeah, no one's allowed. Good, I'm glad. So. I've done.
We're well trained.
I've done a number of these where people show up and they got the fly, Nikes on, and the entire thing is 3M. You can just see white sneakers walking around your volume, and you go, someone's gonna go in their socks, or we bring slippers. But again, the power of the hardware allows us to hit those farther off targets or more complex targets without loss in between. It's easy to do maybe 50 feet out, but can you do 5, 10, 15, 20, 25, 30, 35, 40, all the way out to, in some cases, I think to switch measurements, we talk about 50, 60 meters, which is a lot of feet if you do the math. And so again, we power our cameras appropriately. Hopefully we can kind of give you a little bit of an example of that later on in the conversation. And then QTM. So I'm not going to talk about QTM. I think it's best to actually show. I think QTM is a capture software. It's got wonderful scripting stuff. But I'm actually going to hand this conversation over to Jeff.
Well, I think one thing worth mentioning too.
Oh, yeah, jump in.
Look at that point is, like you said, the daisy chain simplifies things pretty drastically. Yesterday we showed up, everything was in cases. We had all the cameras up and connected in about 90 minutes, and it makes things a lot more streamlined and a lot easier to just, if everything's connected, you're ready to go.
Yeah.
It's not running a cable for everything. It's not, like you said, trying to load balance switches and figure out, hey, is this going to work? Why isn't it working?
Yeah.
You connect it and it's there.
I do one-man shows when I go to, for instance, universities, and I'll bring 12 to 24 cameras with me in Pelican cases. I don't need anybody else to run the system. It's just me, and I'm up in an hour on tripods, no doubt. But still, the ability to just single-handedly run a system, that's not something that's easy to do. Usually, you have to have a cadre of people who can, okay, you do that, run that. If I'm mounting things, that's a day, potentially, or half a day. But we've got that flexibility in there, so that's a really great point. Thanks, Jake.
Question.
Yeah.
I love daisy chain. That you guys nailed it on that. But the customized cables are great until one goes wrong and you can't run to the store.
That's true.
And also, and that's just kind of a comment. Like I love the daisy chain. I think it's worth it.
Uh-huh.
But because they're customized, do you just have set lengths that you just hand out, or do you go to the space and find out what the camera configuration should be, and then?
So our standard is set lengths. So we have 2, 5, 10, and 25 meter lengths are our standard lengths. We can do custom lengths if it's a kind of bespoke setup that you know where the cameras are going to be and you want lengths that work for that.
Yeah.
But also they're custom in that they're not generally used, but it's not like a proprietary connector. You can go on Mauser, DigiKey, and buy the connector, buy spools, make your own cables, so you can have backups ready.
Yeah, that was.
We're not in the cable business, right? Like we're not making money off cables, so we don't have a vested.
Experienced that.
Yeah, no, I know, yeah.
It's like,
And so we don't have a vested interest in making our dollars off a margin from selling cables, right? We want to get our cameras in your volume, and we want that to be an easy solution. So, yeah, you can go to those places and put together your own line. I think that I don't know if there's a theoretical limit, but I mean, 25 meters. A lot of people in the States don't have a sense of how long that is. That's 60-something, that's over 60, 70 foot, right? Yeah. So that's a pretty good distance between cameras. So whatever it is you're doing, yes. Mr. Derek Crosby.
As much as it feels like a yin or yang conversation about daisy chaining or running individual wires
Yeah.
because of the issue of like, well, if the first camera in the daisy chain goes out, you're kind of, it depends on, you said they're hardwired through, so maybe it would be a disaster. But if it then is, for whatever reason, because the daisy chain doesn't work anymore, as part of flexibility, I would prefer a system where I can either daisy chain or run individual links, because if I have cameras that I never want to touch ever again because they're in a really strange position or way up in the rafters and I don't want to go up there again, I'd like to just run individual cables because it makes me feel better about, like, if something's wrong, I only have to figure out what that one problem or what that one camera's problem is, not what the entire chain is upstairs.
And to that point, with, for instance, these Arcus cameras that would be applicable for something you would deal with, you'd only have 5 because each one is powered, like there'd be 5 cameras powered by one.
But that's 5 problems.
No, that is to that point.
But I guess cameras in the chain aren't connecting, but the first two are, it pretty obviously points to like the cable between those has failed. If you have one camera that's not connecting, but the cameras after it are connecting, something in that camera has failed. So even though they're all part of the same chain, if there are failures, it's usually pretty obvious what point in that chain is the problem. And the vast majority of the time, the rest of that chain continues to operate fine.
And one of the things, and again, that's assuming that we can diagnose everything with like straight up QTM with Talk to Us. If you're working with a situation where you're not using QTM, but you'd be using our cameras, we could work with you to build up utilities that would actually help you do the same identification. And again, that's a point we want to kind of highlight, that we're not selling stuff at like Best Buy where these are the cameras, these are the cables, this is the software, if you don't like it, move along. Because that's not how we've done our business for 35 years. There's always something, a use case that we haven't seen before, and we've had to work around that with the customer.
I guess I'm just not sure why there's this fight about like daisy chaining 5 cameras together when you have 2 ports on the back of the camera. Why not just plug in one port, leave the other one, the daisy chain, off, and then just run multiple cables from the hub to the port?
Yeah, I mean, as far as why we did daisy chaining, and that's kind of the direction we went.
It's a matter of the power injectors. Then you'd have to have like a power injector or power for each one.
Yeah.
Like a power hub.
But if you have a PoE hub, then what does it matter?
But so our cameras don't, it's not PoE. There's extra connectors that supply the power.
Okay.
So if you plug PoE into them, they just won't be powered.
Gotcha. Okay.
But I mean, again, that's
I mean,
an important
actually
distinction.
really good feedback because there's no reason why we couldn't make like a cloud splitter hub that you plug the power supply into and then just have a single of each of those cables to a string of cameras. In theory, there's no reason why you couldn't do it. It's just not something that currently exists.
We haven't been asked for it yet.
Something that would be fairly trivial. I mean, if it was something where a studio came to us and we're like, hey, this is a showstopper, it's something we could make to make it work. So.
I mean, I've just worked on some stages where like they've got like a silk ceiling or something else where there's like a camera sitting right there, and it's like you have to take the entire silk down, or it's just a pain to get up there. So
Yeah.
I'd rather just have one cable going up there, and then if I have that one out, then I can just disable it or move on and fix it later.
Maybe to have like a separate splitters from the
The
main
power,
or
yeah.
something
Yeah.
I have
Like a power hub where you can plug in.
I have the same suspicions as he has, like what if the chain goes wrong. But if you have actually splitters that don't go in the camera, so not necessarily go in the camera or out of the camera, but the splitter alone,
Yeah.
branch the tree and go to the let's say high camera or something, and then you don't touch that cable at the end. So like sometimes you have like a camera that are back in Sweden we had the cameras that were at 5.5 meters.
Yeah.
So like just to climb up to that, it's a problem if anything happens.
So we sort of have halfway there. So this is how we inject the power. We call it a power injector. And so it splits the power and data. There's no reason why we couldn't have one of these that just has multiple camera ports on it so that you could have them segregated the way you wanted to. It's not something that currently exists, but it would be fairly trivial to make. So yeah, that's good feedback.
Or could you just use more of those?
No, because they don't split that way.
Okay.
But yeah, it would be, I mean, you could just make a larger board with more connectors on it. It would be, yeah, fairly easy to do.
Okay.
I say we pass that around if people want to look at it.
Sure.
This is kind of like, it's like we call it the power injector, but basically there's the data, there's the power, and there's the camera. So when you connect the power to it, that's how we kind of pass everything through. Again, it's just a question of we haven't been asked. But for any kind of install like that, it's a fair question, and it's a legit question. I mean, getting involved in custom places that people aren't moving cameras around and no, that's staying there for the duration of whatever it is we're doing, the next 18 months to 5 years. You don't want to have to keep getting a cherry picker and stuff like that. So it's a legit. Actually, I think that's a legit comment on that. So
Yeah.
door's not closed on that solution.
Yeah, and I mean, if you're gonna rest your laurels on flexibility and having the ability to daisy chain, then why not just do it both ways? And then
Yeah.
you have ultimate flexibility. You choose however you want to do it. If you want to daisy chain 5, 10, 15 on that wall and none on that wall,
Yeah.
you can totally do that.
I love this idea. I want to be really clear, not resting. We're balanced on the balls of our feet. We're dancing. We're not resting. Because again, you actually nailed the point. We don't know as a company. Maybe I do. Maybe Jake does. But we don't know as a company this use case challenge. But like I said, if it's something where we're just building a different kind of injector or a different kind of power port, that doesn't seem like a crazy idea. So anyway, great questions though, and I love this discussion. That's what I was hoping for. Yes, more. Gimme, gimme, gimme. So I think this would be a good segue though to talk about. Okay, great. We've got cameras, daisy chaining, powered. We can figure out how we get the power to it, but the stuff that's actually driving the capture is QTM, which is an acronym for Qualisys Track Manager. Yeah. Three-letter acronym. Alphabet soup. So what we're going to do is we're going to kind of get into it. And so,
Should we do a coffee break now and then we can get set up?
yeah. So what we're going to do is we're going to break briefly for coffee, 5 minutes, freshen your coffee cup, get a bagel, whatever's out there, and then we'll get going on the QTM side of stuff. Sound good? All right. Good to have you. Eh. It's a good point, though, and I think actually that's a legit.
It is. Because the truth is, I agree with him that the daisy chaining thing it's nice, but it's not as nice as sometimes we portray for that very reason.
Well, yeah, because there's some biomechanical labs that want to like change here and there, so it makes it easier for those here and there, but not the ones that are permanently mounted. You know, they do have that hesitation.
Well,
Like
for
that's one
instance-
of the hesitations in that permanent outdoor drone space. They're like, well, what if one goes out and we got to go get a big lift code
Yeah,
to go
exactly.
get up there?
Well, the Sphere is going to have the exact same problem, because if they put like 90 cameras up there and they're Actually, Will's been very nice to volunteer to put the suit on. That's fantastic. We have him. We have him for the next hour and 20 minutes or something, so that's awesome, and that's all we need to kind of demonstrate that. I want to demystify one thing about, like, oh, what, Qualisys. Okay, fine, what is your marker set? What are we going to have to deal with now? If you've noticed, this is 57 markers. It shouldn't come across as being wildly unfamiliar as to what you're used to dealing with. We have an upper and lower sternum. If we turn around the back, you'll see basically this is the marker setup for the back. So it shouldn't come across as being wildly unfamiliar. Here's your arm, forearm roll. So essentially, that's the marker set we're using for the solve we're building right here. It's not dyed in the wool. You don't have to use anything that we're stipulating. This is kind of what we're working with right now. A lot of it is actually built off of the same biomechanical stuff that Vicon uses. So for full body stuff, it shouldn't necessarily be a surprise. So any questions around that? Any questions around the marker set?
You see what I'm saying right here?
Why do you do that? Why do you not do that? Or we don't care. We don't care? Yeah.
Are you locked to this marker set, or are there ability to do other marker sets?
Yeah.
Or are there offers?
Yeah, we're not locked really to anything other than what we would recommend that would be maybe like a lot less. Yeah. So our system has integration with like the Mattis Glove system. It integrates directly into the data stream. So in QTM, you'll get on the joints. So there's no post integration. It's live. So you can get that. Yeah.
So how does it, like when you radically change the marker set, depending on what you do and how you add markers, how does it change the auto ID?
So, Jeff?
So the auto labeling is done through the scripting stuff that I've developed. And what you do is you have an example of the marker set that you want that you save, and with the description of how the markers relate to each other, and it will use that from previous data.
So auto ID will still work no matter what marker set you pick.
Right. So you you can do it with any marker that it's independent. There are a few heuristics that know how to look for like head and foot and waist markers to get the whole thing started. But if those markers aren't there, then it will just do it fast. It has to have something to start with. Sure. Is the one thing.
So as long as it's predefined, it'll load up automatically every time.
And actually facing to your right. Yeah, we ended up making that the y-axis.
Positive Y.
So what we'll start off with is a range of motion.
Nice. Racing day.
You can, hang on, did that wrong. First operator error. Let's do that.
So one of the things we're actually going to show you is obviously we're going to set up him as
So wrists, elbows in
Yep.
and out, arms up and then down, and then do a lunge one way, and then a lunge the other way. Usual thing, give us an upper body twist. Yeah, you have to only do it once. There you go, like that. And then back to a T-pose. That should be enough for now. Okay, you can relax. So this is what you get, and this is the first time we've worked with him, so let me see if this auto labeler actually works. Fingers crossed. Label now. Let's do, there we go. So this has taken the data marker set from somebody I used at SIGGRAPH, I think. I'm not even sure where it's from. But it labeled all the markers for me automatically. And then what I'll do is I will change the prefix for this.
I was going to say, can we get it onto?
It's
awesome.
Will, right? Yeah. Thank you. So we'll just call it Will. That's the Will marker set. And then we'll do, so what we'll do is automatically we'll fit the metahuman skeleton. So we'll just do male, medium, normal weight.
So I want to stop there for a second and really point this thing out. That's a little piece of magic. We talked about being able to basically take a predetermined or predefined skeletal hierarchy, naming convention, joint lengths, and everything, and fit his marker cloud around that definition. So what Jeff has is just highlighted a preset for MetaHuman. The real promise going beyond MetaHuman is that we could actually do that same process for any internal production, verified skeleton that you're using for whatever it is you're doing, and get the exact same results. We're just using MetaHuman because it's very easily translatable, but we could basically have project settings for that show, for that project, that you could get access to via the scripting and the interface. So to be totally clear, we're using MetaHuman as an example, but it's readily able to be converted to whatever it is you're doing for your project.
And I think the big thing to focus on with that is like, doesn't necessarily need to be humanoid marker set.
Exactly.
Just go ahead and stand out in the center.
You have prosthetics, if you have different, nuns.
So there we go, and we're tracking them, and we're solving metahuman skeleton onto Will. And then in here, I just need to change this to Will. Oops, wrong one.
You got to update it in the
I'd
editor.
like to just update animation in editor, and there we go.
There you go. So again, we had no idea Will was actually going to be putting on the suit this morning, and the idea that we were able to get at least a starting solve setting up and running that fast, we're quite proud of. Although there's an elbow issue.
Off. What's going on there?
Yeah, walk in the volume, walk out of the volume.
Better now? Yeah, better now. All right.
What's the latency from
This is right click, not tracking. What happened? Did we lose a marker?
It's one machine, so everything right now is running off of one laptop. So both Unreal and QTM. So it's the latency, Jeff, I mean, if you're running off of one machine and then you're not networking those two together, latency is going to be...
It's going to be just 1 over the frame rate,
Yeah.
more or less.
Well, I mean, for DCAM, it's important, right? Because you're trying to look through that.
Yeah, what frame on that? And the marker's got stuck in the right foot.
Yeah. So I think that, like any other capture software, it's all CPU intensive, it's all numbers. We're not driving anything other than just coordinate information. But QTM is light. As far as I think that's something that we would, it's basically, Jeff, you said it was one over frame rate?
Yeah.
Yeah. Well, we're going to set something up. Like Al's got like a VCam, so we're going to be able to show you that. So after lunch we'll get that going. So we'll demonstrate that after that, and you can kind of see what we're showing. It'll be self-evident.
All of this. This whole screen here is all.
Oh yeah.
Yeah.
Will, is that where it carries on within each session? Like if hypothetically there's a power outage, all the cameras go down?
Yeah. So you have contiguous or continuous project settings. So if you set it up and save it, you can just refer back to those settings and everything comes right back up again. So whether that's for the character definitions, whether that's for anything else, you go back to the project settings and you're going to be able to recover them unless somehow that file got corrupted,
The project settings aren't something you can manually save. Anytime that you make a change to the project settings and apply that change, it's automatically saved.
So then if there is a hypothetical power outage and you're able to review it tomorrow,
Yeah.
once the testing's done, so you will be able to kind of back up and running.
Absolutely. I mean, it wasn't a power outage, but when we would do SIGGRAPH or GDC, very often we calibrate with our guys like the first day, and we just shut everything down, open it back up, and they're back to it, and we fire up the project settings. We don't have to I think even one time we don't always recalibrate. We basically just keep.
But the show opens at 10 and we don't have to get to the booth until 9:30 because we barely have anything to do. So
Yeah, but
we're
I keep
rescheduling.
us out too late, so we don't really show up for 3 weeks in a row.
Area's gonna say
Hey, you're giving away the dirty secrets. But and what we're going to hopefully do after we show this is get into an actually how, like what is calibration? What does that process actually look like? One of the things that so first of all, I don't want to get too far into that situation, but does anybody have any further questions around like again what we're doing is we're taking showing the potential of being able to take your production skeleton into QTM directly into, and again, this is going into Unreal, but it could be Frostbite. It could be whatever it is that's going to basically accept the stream, however you're visualizing. How many people here are using Motion Builder or Unreal as just visualization? So most of you guys, is there any other package that I'm not listing or thinking about that you visualize in, other than those two? People using Blender? No, you can't do that with Blender. Not for visual, just those two, right? Yeah. So we have plugins for either of those.
How do you, in QTM, how do you expect to define the overall stall, like, so like the measurement of, so obviously the measurement of the skeleton.
Yeah.
How do you, if you wanted a better fit to like match the collarbone height or match the hip height, how would you go about doing that? For better real-time stalling or more accurate real-time stalling?
You can fit the skeleton however you want. There's a model pose definition that is fed into QTM, which is the relationship of the skeleton to the markers.
Yep.
And the tools that I have for that are currently a set of tools in Maya. So you can bring in the definition into Maya with your character, describe the way the markers are attached to the segments of your character in Maya.
So, there's a production day or production morning, and director says, "Oh, I want to see more accuracy here, there, or whatever." In order to do any adjustments on this, he goes in Maya and then come back to this.
If you want to do hand adjustments, so what I showed was a script solution
Yep.
that was based on an existing character definition.
Yep.
And these are things that you can set up ahead of time. So hopefully, most of the time, you've got fair warning on what characters and stuff you'll be working with that day, right? And so that you can set that up
In
ahead
a
of time.
perfect world, yes.
In a perfect world, yeah.
But you couldn't make like on the fly changes in QTM.
At the moment, there is not an interactive editor for this data in
Okay.
QTM.
Okay.
Generalized on-the-fly editing of it is not easily available inside QTM. It would be stepping out into Maya, and then it's a matter of exporting a file into an XML file that we read into Maya, and then it'll show you the character definition there.
Okay.
And then you can make an adjustment and then read it back into QTM. So it takes a couple of minutes.
Sure. Okay.
But it's not. You still have to kind of bounce off the file system a couple of times.
It's an important question.
I know.
I think it's an important question. Who here would want that? I mean, I would imagine everybody would want the ability to just stay. No, right. So, but that's feeding into the reason for this. We don't have that right now. And a lot of what Jeff has already demonstrated here is scripts that we've written to kind of facilitate that workflow. Why not have something that gives that more on? Because, I mean, I've worked on mocap for 20 years. I always know there's like, on the day we're about to go live, I got a new rig. Now it's slightly different, but I've been working off of assumptions. Now I have to make these changes. So a lot of what we're doing, again, is we're also fact-finding and figuring out where the gaps are. But we've built this stuff so we can basically build other things as well.
How about retargeting onto like a troll or some non-humanoid larger character with large, differences in proportions? How would that work?
So there are going to be cases where you have to resort to traditional retargeting techniques
Okay.
to handle stuff, and so the
So-
usual retargeting tools will be.
So it mostly does one-to-one right now, is the retargeting?
Say again?
You're mostly doing just one-to-one, like before we went to skeleton, it's the same proportion as the...
Yeah,
this global optimization?
This is a globally optimized, yeah. This is an open sim solve.
Okay.
So anybody has access to the open sim tool set.
Okay.
And yeah, so basically what you do in the solver definition is you align markers with each segment, you know, what markers to drive a particular segment. A marker can be assigned to more than one segment. A segment can have as many markers as you want. And then you describe the degrees of freedom, how many rotation DOFs you have, and then the root always has the translation as well. One nice thing about our solver is that, I'm not showing it here, but you can have translation DOFs in it that work quite well and use it for the spine. And so you can have expansion joints built into any of the segments, which I found really works well when you're doing animal captures, because their spines work differently. And in particular, like did a horse capture where the T-pose of the horse, of course, is standing up, but as soon as they went down to like nibble on something on the ground, if you didn't have an ability to do the expansion of the neck segments, it just would not work. So it's
Can you tweak the constraints? Like, can you say, you know what, I don't want it to like I want hand leeches on, or I want you know, foot contact to be more, and I'll let the spine float wherever I want.
yeah, all of those things are available, but like I said, not interactively through software. But you can do it in the Maya tool, or if you're hardcore, you can edit the XML file.
Yeah,
But
that'd be a big thing for us to be able to dynamically change.
Yeah.
Because on set, especially, you know, we've had some things where we had a demo we did with Marshmallow Man for Ghostbusters that is, you know, ginormous.
Yeah.
It needs to be in,
Oh, I saw the
in
demo, yeah.
body space. Yeah, and but then he picks up a car, right? And like, you need that to be in world space and accurate so that he can pick up the car and toss it.
Right.
And so that dynamic ability to tweak things either shot by shot or even interactively through a constraint or a button that you can switch on and off or dial would be amazing. Because
And
then you
some unfortunate motion builder still is kind of does that fairly well, but it doesn't use a global optimization solver. So the data you get is rubbish, but the controls of it
Sure.
are really good. You can do constraints and
Well, I mean,
live
you can
and all
do
that.
that in Unreal as well, but the thing is I don't, I want Unreal to be my visualization, just like I want motion
Not
to
your
be
solve.
my visualization. I don't want to sit there and create an entire game rig where I have to have a
Yes.
controller and put buttons on.
With like 18 interfaces.
Yeah, 18 interfaces. Notice Steph's taking notes on all these points that we're talking about. So thank you for being one of the many things you do, also stenographer, so I appreciate that.
Well, this goes right back into my meetings with the head of product. So I give him feedback from what we hear from everybody, and he is the one that talks to the development team then and says, this is what we're hearing from the audience, from the market, this is their needs, and we try to work it in, you know?
And the minute we get into, like I said, I mean, Jake can attest to this, people come to us because they know we can solve it, not that we always have already solved it. We're known for being the kind of like the custom solution people because we've got the depth and dev to be able to address those issues. So I want to reemphasize the fact that although to your point and also to the many points you're making, stop. You're done, you're cut off. Your quota. Yeah, you have to hold up a flag now. But to your point is like we're known for being able to deliver if we haven't already, and that's kind of like the main strength of where we're kind of coming from. So.
That's one of my favorite things about working here is I talk with our CTO at least once a month about, hey, this is something cool. I think we should put some effort into. What does this look like? Can we fit it in? Can we make this happen?
Yeah.
And almost always the answer is yes. And we do a lot of cool things that are maybe not necessarily, hey, 1,000 people need this. It's like 2 people need this, but we think it would be cool, so let's do it.
Yeah, and the project requires it. I think a lot of what we're able to do now is based off of, like, for instance, the scripting that, I mean, Jeff is kind of showing. Can you talk a little bit about, you know, the kind of scripting tools, the process, like basically, like talk a little bit about the scripting environment? Because I know that we have some people who kind of enjoy getting into that kind of detail.
Sure. So we've got Python engine
We should be, yeah. We're hooked into, yeah, we're on the Wi-Fi.
I can find that later.
We're on the Wi-Fi.
Yeah, it's on GitHub.
Oh, okay.
So it's all of the modules that are available to you inside Python. And basically, it gives you access to all the settings and all of the stored data. We're still working on getting some interactive stuff built in to the interface. What I use it for, and everything that you see here, the standard menus in QTM go to here. The help menu is usually the last one. Everything else that you see from scripts to the right of that are scripts that I've written to do a whole host of different things. There's online help with all of it, and so there's documentation on all of the scripts that we send out. And right now, it's not part of the official distribution, but it is something that I make available to all of our entertainment customers and others, because we've been using it for a variety of things.
Well, I think even the kind of backstory of how scripting came to be is a perfect example of things that we thought was cool. Is our developers have 20% of their time is available to work on stuff they think would be cool that's at least semi-relevant to the product. And so scripting was one of our developers was like, hey, I think this would be cool. He worked on it for a year and a half and got it to the point where it's like, yeah, we're going to release this and make it part of our software. And now it's a very useful tool that a lot of people are using to be able to make your own tools within our software. And so it's a great example, but not a unique one of, hey, I think this would be cool. Let's do it.
I think another interesting thing is, so there's scripting which is built in to kind of ease the pipeline. In other words, you can customize it the way your environment rather than you forcing you guys to work in our environment. You know, we like to work as a jigsaw puzzle, not the whole puzzle itself, or define the rules of the game. One of the things that actually Jeff actually just turned off that he showed you was very often motion capture stages have the mocap supervisor who basically have designed the system, built everything out, and then you have, and I don't use this term pejoratively, I was one, the operators, the people who don't necessarily know every button and understand everything, but they know enough to be able to run the system. And so one of the things that Jeff is actually showing you here on the left-hand side of the screen is that Jeff's, I come up with a different name for it every single time, but Jeff, you call it the?
Workflow panel.
Thank you. So it's the workflow panel. So for those teams that are running complex or maybe just shows or projects that have predefined processes and pipelines, you can actually define a panel that for that project, click here, do that, turn this on, turn that off. Because if you were to give someone operating the system access to every single I think there's 3,900 buttons or operations you could run from QTM. That could be overwhelming. So if I'm running like a live show, what we can do is we can provide you with this panel where you can just define these operations. Do this, don't go anywhere else. This will help you reset, calibrate, start, stop, all these other things. And that gives a huge amount of flexibility, but also definition to what it is we are doing here today for the operators on the stage.
So can you say that as like a very specific
Yes.
profile for
Every project you're running could have a completely different layout. And those have got, I think there's 12 or 14 buttons there. It could be 3. It could be as many buttons as you require for that project or even that day for that project. And again, for me, as someone who running a mocap stage, and I don't want to have to sit over and go, not there, do that. Okay, I want to be able to have someone trained on the parameters of the project. And that to me is a huge help. It's not rocket science, but it's really, really helpful. And we've built this, Jeff has built this in here to allow for, again, ease of operator use and define pipelines. I think that's cool. Anyone else think that's cool? I think that's super cool.
So the way it works is that we have what we call the QSI, Qualisys Scripting Interface. So that's the set of modules that you can program with inside Python. But every one of those is also exposed in a REST interface so that you can have an
No, no, go ahead. That's why I invited you here, actually. Stir it up.
But because because you've got everything in Rest and Python, in theory, if somebody wanted to, they could just integrate it into Unreal. And why even have like QTM?
You could run it headless.
From Unreal, right?
You could potentially run it headless. Is that what you're asking? I mean, yeah, essentially.
Leave it to Derek to cut to the chase. Yes, those are options that we're looking at right now are headless options for controlling the core technology that does all the talking to the cameras and all the setup, and then streaming the data, and then controlling it without the user interface on top of it.
So it is essentially abstracted enough that we could help you design something that does. I know. Start to think it does.
The last few years, we've actually been undergoing a pretty significant rewrite of some of the core IP at our company to make that possible. And so we're hoping to have something like that soon that we can show.
The key to how we've done what we've done up until this point, and I've been with the company for a year, so I don't have even the pedigree and experience, but the key to what we've done so far is that not everyone is using L4000 operations. They may be using a very distinct part, but the fact that we can isolate that smaller section of our operations that are good for underwater drones, or we're doing robotic stuff, or we're doing big shoots at Beyond Capture, is kind of testament to the power of QTM under the hood. Like, it allows for that level of specialization, but still without having to sacrifice stuff. I have to give up this to get that, which is what we think our strength is. So.
Andrew, does your team have a lot of experience working in more like in-camera VFX spaces, like live broadcast, virtual production, concerts, where you're doing either LED wall tracking, or more complicated?
Yeah, no,
Crowds
well, as far as like large volumes and venues and stuff, that's not so much a challenge. I think the biggest challenge, I'll speak very frankly about Qualisys, is that someone said it yesterday. We had a little mixer here last night. 6DoF tracking for rigid bodies and stuff like that is actually something that we've found in the past we've been lacking. Like, we didn't have it nailed down the way it needs to be for like virtual production and that kind of thing. So we're actively working. I don't know how close we are, and I'm not going to hold Jeff to the actual time, but we're real close on actually taking the 6DoF solve we currently have and actually radically jumping it forward, so we can not only give you position but really great rotation as well. And that's the challenge with optical. I can nail down position really, really well. But everything else is down to, well, maybe I can use inertial or something else.
Yeah, I was mostly curious because I know there's been, in the last 5 or so years, a more rise in optical mocap integration within certain other less common media servers like Pixera, Simulate, Digital Christie, Pandora, and they do a lot of really, not just live broadcasts or kind of like live events, but a lot of really interesting like installations and interactive experiences. So I'm curious if that's something.
There's an installation at Virginia Tech called the Cube, and they use our system, and it's all very live, like in space. It's like art interactive. A lot of universities actually have this. University of Texas at Austin.
Oh yeah, they do a lot.
They also do, and they use a Qualisys system, and so we've actually been able to piggyback on all their research and feedback. And that's what's driving a lot of the stuff that's taking what we have for 6DoF now and actually driving it forward into what we're doing. So we're thinking, at least within the next couple months, we're going to have an update to the 6DoF. I mean, is that a fair?
It's actually supposed to be in the January release.
Okay, so we're that close.
Have you integrated IMUs into it to try and get a more tighter feedback loop and less latency between the 6DoF?
We are absolutely. I mean, Martin has been playing around with IMUs for a while now.
The update to the tracker is going to set us up for doing that because it's a completely Kalman filter-based approach, which is perfect for integrating inputs from different data devices. And so we're getting it working with our technology, with the optical stuff first. And then once that's buttoned down, then looking at hybridizing it with other stuff is going to be the next steps.
Yeah, so we're definitely developing in that direction.
So with the IMUs, would that be using more like active tracking system? And if so, would that be more like a plain IR? Would you have like unique identifiers, like
I don't think we're really nailing down like specificity like that. I think it really comes. I mean, IR, having a unique identifiers for IR tracking. We're always leery about mixing passive and tracking together because you always have to default to the lowest possible frame rate to make it all kind of work. I think that it's unavoidable for certain venue situations where you need, in weird light situations, that IR that you can rely on every single time. I know there's some people who work in venues where the lighting scheme is literally changing every second, let alone every minute or every hour. And so IR is going to play a large role in that. So what I will say is go back to what he just said, is that right now we're nailing down the optical, but there's no way to avoid that IMU integration at some point. And so what that actually looks like, I don't think it's got to be this, it can't be that. So we're in active evolution on all that stuff. Is that fair to say?
Yeah, and supporting different devices, we've also reworked what we call the Q device interface, which is a standardized interface for all kinds of external devices. It's mostly for life sciences stuff, for treadmills and work plates and things like that. But it is open to anything. It's how we do the gloves, glove import. Manus Gloves has a Q device for it, that sort of thing. And so all the framework is there to bring in the data from whatever source you want.
And actually, that's a really good point. A lot of our flexibility around external, like adding peripherals or adding what you might call extensions of the systems, that's kind of like in our DNA already because of the stuff you just mentioned. Like treadmills and force plates and all these kind of biomechanical stuff, that's just literally presenting as another external data source that we have to integrate into the data stream. And so that's something we're always, 35 years of having to be comfortable with. So whether it's an IMU or whether it's, like a treadmill for a horse, that's just, we just have to figure out like the normal problems. It's not a new challenge for us. Did I just invent a brand new?
Horse treadmills.
Trademark.
Treadmill, horse treadmill.
Alamo has an underwater horse treadmill.
Nice.
Really?
You forgot an adjective. You can make it more exciting.
Oh, more exciting. Underwater saltwater.
Yeah. Because the water helps them, like, there's
Yeah.
so it's easier on their
Underwaterhorsetreadmills.com. Yeah, so what we're doing here is we're trying to essentially make, and with all the feedback we're getting, so this is all included, basically make it so that you're not fighting uphill an environment that you're being kind of given to try and make your project dreams come true. We're trying to basically make it so it's a lot less filled with friction trying to just get the data you thought you captured onto the stage, whether it's operational with the panel, whether it's in being able to use your skeletal systems and basically fitting the marker cloud around at the point of capture rather than after trying to make it all work, shoehorning it in. And then also with the idea that we're keeping notes and we're keeping track, and so presented with the project, we're not going to come back to you and say, yeah, that's not on the dev map, so we're not doing that for the next 3 years, which I'm sure you've heard from other people. Yes?
What are your options for like finger and face tracking?
Well, fingers, I mean, both finger and face tracking are kind of very, very particular and specific solutions. So right now our system works with Manus. It's a direct integration into QTM. So with Manus gloves, you would see the finger, the metacarpals working live at the point of capture. Face capture, it's kind of like whatever it is you want to use. I mean, you could use, ArcKit, you could use FaceGood, FaceWare. It's all basically, as long as there's a time code, you can just stream it into your endpoint or your recording point.
So speaking of time code and/or frame rates on the cameras, what is the max frame rate on those cameras?
On the Arcus, they can go pretty darn high.
The A9s can go, or A5s can go up to 1400.
1400 at full frame.
Yeah, 1400 at full frame.
All right. And then time code integration, like once you're talking about Manus and so forth, like that becomes a nightmare trying to get everything under one time code frame. So.
Right. So actually, maybe, does Peel deal with that kind of, would that be?
Right now, we're running off his SIMD time
Yeah.
code, and Manus integrates with us directly, so that's time synchronized. But
So it gets striped with the same time code that you guys are getting.
Yep, but then we also have, so behind Steph, we have a sync unit that we have lots of different options for import and output of. We can have event pulses, we can have different time frequencies, input or output. So you have a lot of options for
Go play.
synchronization.
How many people deal with peripheral solutions outside of like face cams and fingers? Does anybody play with anyone play with drones? Anyone play with other systems? Or anything or is it mostly face and fingers? VCam. Okay, so VCam. Yeah. Well, so the wonderful thing about being here is that a lot of the stuff we don't do, Al has and PLDev has actually built a lot of kind of complementary solutions to those kind of things. So hopefully you can tell us a little bit about that this afternoon to kind of how do we solve those issues, because there's only so far we can reach into your environment, and I think a lot of PLDev can actually help consolidate a lot of those signals and triggering and slating and all that stuff, and beyond, way beyond. It's not just that. So, good?
Question.
Yeah.
What did you say specifically with Manus? It's integrated in QTM?
Yeah. So you can set them up as devices inside QTM, so you're not having to meet it at like Motion Builder or at Unreal. It's actually recording.
We can use your old company, the Stretch Sense.
Yeah.
So, like if you can integrate it in Motion Builder.
Yeah.
Right?
Yeah, absolutely.
Okay.
Absolutely.
Andrew doesn't do search sense.
I can't speak about what they're doing from the point I left. So, so yeah. So what time do we have here? 11:40. Have we answered any questions that are outstanding from any of you guys at all? Anybody? We haven't talked about anything.
We're done with the prop. I have a few questions.
Okay.
I want to see this first.
Who's your favorite Teenage Mutant Ninja Turtle?
Donnie.
Mine?
Yeah.
Raphael. It's kind of like a bit of an anger issue. You know, I can respond to that. I'm wearing red.
I just said that.
Oh, you did? I'm I'm wearing red, so.
Does QTM, if you wanted to do a passive finger tracking solution, is that something that QTM can offer?
Yeah, I mean, again, it's optical, and you can incorporate different marker sizes, so you can do the finger thing.
Oh, you have the different finger sets.
So we have two different, we have a claw marker set that basically treats the middle fingers like they're attached to the outer fingers to try to simplify things a little bit, and then we do have a full finger marker set.
And actually, we have an interesting camera solution. So I think one or two of these cameras are like 826s. They have a 26 megapixel camera sensor. So dense, you could actually set up an array of those and get really nice finger capture on those. They're not necessarily.
How much more are those? I mean, like percentage-wise, are they double the normal cameras? Or?
The ones that we would install at any kind of marker, any kind of stage we're talking about would be between the A5 and the A12. The A26 is, yeah, so you're going to get a lot more, but I wouldn't use it for like distance. It's just you would use it for more accuracy because you have a denser sensor in there. So, but I mean, the ones we use at Beyond Capture with that 120-foot throw, we're using A12s and they hit the back wall every single time.
I mean, the back wall was interesting last
But
time trying to do fingers or.
yeah, so A26 is an array of A26s. You could basically set up like a smaller 20 by 20 volume, and then you can get really nice finger data.
What does your camera recovery look like if someone were to severely bump maybe 5 out of 45 cameras? Would you necessarily have to resort back to another calibration? Is there like an option where you can?
Calibration takes about a minute. Calibration with our systems take about 30 seconds to a minute. So if you do need to do a full recalibration, it's not like, okay, everyone take a coffee break. It's literally wand and then we're done. For specific, Jake could answer that question.
Yeah, what happened there?
Hey, Jake.
Yo.
So Kat had a question around camera recovery. So we have a calibration set up. and somebody touches the truss. Death, instant death by electrocution. But we basically, we've knocked somehow 5 cameras out of the array, out of alignment. Kat wanted to know about like what do we have for like what can we do about recovery of those cameras?
If we wanted to avoid calibrating the space, can there be some sort of temporary like Band-Aid solution where you can like recover individual cameras at a time if you don't want to kick everything out of the space?
So I'd say a couple of things. So the first thing we do have, you can barely see, but in the bottom right corner, there's kind of a picture of the wand with a little green box around it. So that's your like calibration indicator. And so that's constantly checking, are the cameras agreeing on a position?
It's literally bottom right. It's green right now. It's usually red if there's a problem.
So that is a parameter that you can choose. What it is defined as is how much the cameras need to agree before I say it's a problem. And so when it gets to a certain point, if that camera is outside of that parameter you set, it just won't contribute to the 3D position anymore. And then that indicator will turn yellow and it'll say,
What's the question?
this camera had all your lights are orange. That you should probably calibrate. So you'll at least get a warning, and it also will be thrown off your 3D reconstruction.
But you can change the colors to whatever color you want. It's like a color picker. You just pick whatever you want. It can be purple. It could be green.
If you said there's a different color to manually notice the camera separated,
No. So if you look at the screen, the feedback in the software, all the way bottom right, it's a green little square. So that means that, first of all, when that turns yellow or red, it tells you we've lost. And you can click on that and identify which cameras have kind of fallen out of the calibration. So that allows you to. Yeah, it gives you basically a sense that someone's done something to the calibration, and so it doesn't agree with where we know the cameras are to what the calibration data tells us they should be. And then
How often has your team, just for kicks and giggles, try to run a state on the same calibration and continue to just refine and only refine, assuming no one has drastically touched the cameras or all more.
I mean, so we go to trade shows as we do for the whole show.
Oh, just continuously refine.
Yeah. Because we don't want to deal with somebody putting the offering in the wrong spot or like redefining locations and stuff. And so usually for the whole week of trade shows, we just refine the whole time. And that's like.
can you actually repeat that for the crowd?
Against the trust that you need to recalibrate.
So I'm sorry, I think that's a really important salient point. Can you repeat, like, so Kat had asked, what if you have a situation where you've got a calibration you're happy with, somehow you've got some cameras that have fallen out of calibration, and so Jake, you had a great answer. I just want to make sure the rest of the team can hear, the rest of the group can hear that.
Yeah, so I guess to rewind a little bit, so we do have an indicator of your calibration quality. So that green box in the lower right corner of the screen will tell you if any of the cameras are attempting to contribute to the 3D representation, but are above a certain error level that you set. That will turn yellow and will say, hey, this camera has really high residuals compared to the rest of them. It's no longer contributing to the 3D reconstruction. You recommend a recalibration. So you at least have an indicator that you have a camera that's problematic, or potentially a handful of cameras if somebody moves a whole truss. But then you have the option, instead of having to redefine your origin, recalibrate the whole space, you can refine the calibration and just recalibrate those areas that are problematic.
Thank you.
Automatically stop contributing to the reconstruction?
So we have, in our 3D settings, you can set, if a camera basically disagrees with the rest of the cameras by a certain amount, then it won't contribute to the 3D reconstruction anymore. And so you can have that set really strict, you can have it set a little more loose, but once it gets over that parameter, it won't contribute to the 3D reconstruction anymore. And so that's really useful, especially in larger volumes, because you might have a camera that's halfway across the room that can still see the marker, but it's really not getting a great read on the marker. And so then it will basically self-isolate and say, hey, I can't contribute because I don't agree with the rest of the cameras reasonably enough.
So I think what might be interesting is if we actually showed you our calibration process. We haven't done that yet, and kind of get you into, we have some interesting features in our calibration in 2D view that deal with things like masking and actual like exposure settings that I think might be very interesting, at least to this crowd. So Jeff, I think it might be interesting to kind of go through and calibrate the space and actually show off things like we can talk about camera groups and we can talk about those kind of things. And also the ease of calibration. What do you think?
Sure. I mean, anything people want to see, we can.
All right, well.
Thanks, Will.
Before Will goes, yes, can we just back up a little bit and can you show, Jeff, can you show what it should look like on all the cameras when someone's out there? I just want to see a little bit more of the interface.
Oh, sorry. Yeah. Okay. So here.
It seems like when he got out there, you just recorded unnamed, and then you used an old template to label him. Is that right?
More or less, yeah.
Okay.
So this is in marker mode, and then we can, to any particular camera, we can go intensity or video mode. So you can see.
Okay. Okay. Cool.
Yeah, I like intensity because it's especially making sure that we're getting, that strength of signal back from the reflection, strength of signal of the reflection, and be able to evaluate it like that.
Record the video?
No.
So the way our system operates is the cameras are doing a lot of processing on board, and so all of the camera settings, how long you want the flash time on, how bright something needs to be before it counts as a marker, is all done on the camera. The only thing that the camera is setting back when they're in marker mode is the position of the reflections that they see. So Jeff, can you open a data info window for me?
I'm sorry, which one?
The data info window?
Oh, like here?
Yep. So right now that camera is only seeing 3 markers, or 4 markers. So that's all the information that the cameras are setting back. So that's another one of the reasons why we can daisy chain all the cameras, because the data that's coming back is very small. And so basically it says, I see a reflection at this XY position on my marker, and if it's this size in the X and Y direction, and then the computer does the reconstruction based on the calibration. And so if you have the cameras in marker mode, there is no video data going back to the computer. It's just basically that text file.
That's why the latency is low, because we're doing an onboard process.
And so that's another thing that makes it very easy on the computer to run, and you can have the computer running other things that are more intensive, because all it's doing is basically dealing with the text file rather than trying to parse through video and things like that.
So if someone wanted to, they couldn't like take a snapshot of like if people had different calibration processes or workflows that they wanted to do, like scaling volumes versus capture volumes and things like that, where have them in a pose and then like take a snapshot and have marker data and a video snapshot, one frame or even video that can sync together and overlay for
Not with the same cameras. I mean, we do have like reference video cameras that are made to be color video that people often do to have like a couple positions of streaming video. But with these cameras, they are either in video mode or marker mode.
Think about next time having a reference video.
What do you use the video mode for then?
So for, I guess for this perspective, it would just be if you wanted a reference video to be able to look back and say, oh, hey, maybe I had occlusion, let's look at the video and see what that was, or things like that. Often in like the biomechanics segment, it's more being able to give feedback to people of, hey, we noticed that this happened, this is what you were doing when it happened, being able to kind of easily show people what's happening rather than, I always tell people the marker data, it's kind of like you're in the Matrix. Eventually you look at it long enough and the numbers turn into a hallway.
Yeah.
But for most people that they just looks like floating dots. And so being able to have the video is sometimes useful to be able to actually say, hey, this is what was actually happening.
but you can only do that live.
No, you can do that post in the recording as well.
Okay, but
Yeah, that video is recorded
okay.
from the reference cameras.
From a reference camera, but
Yeah,
not
he's
from
talking
a
about
capture
from the
camera.
reference camera. I was asking the video mode on
From
these.
the capture camera.
Oh,
Would you
yeah.
ever use the video mode?
No, basically for aiming or for like
Aiming.
if you see a reflection and want to be able to see what's that
Like what's
reflection,
happening
switch to
there,
the
yeah,
video mode.
when you're calibrating.
Yeah.
You can record this video, but they're just black and white, not very good video cameras. So I wouldn't recommend it.
Yeah.
So I have a question connected to this. So we were talking about a year ago with Martin about patching both of the images, basically just centroid images and the grayscale. In the same way as if you
you're familiar with OptiTrack has this duplex mode
Yep.
that they use with the AI system. So did you do any improvements in that? Where is that now?
I haven't heard any development on it. There may be some spec works happening, but I'm not familiar with it.
Okay.
What was the question?
Oh, are we taking a look at how, the
Interlacing
marker, interlacing the marker and video to do the duplex on one camera?
To do the,
Oh. Yeah, I don't think there's anything in the pipe right now for something like that. I think the approach will likely always be separate cameras
Yeah.
for each, just because the intrinsics of the cameras are so different, have different needs for the different modes, that it's really hard to reconcile getting good performance out of both modes from the same camera.
Yeah.
So, I mean, you might just have one of each side by side, that sort of thing, encased in a unit. So it looks like a camera, but it's really two, that kind of thing.
Yeah. And that's, I mean, essentially, the answer to that question is, there's a lot of, and actually this comes back into kind of like the markerless question we can get into later in today. But we're concerned about quality, and right now, we don't have a pathway for achieving that with one camera that we've manufactured, where we get tip-top optical, tip-top video that can be easily interlaced at the same frame rate. So
the ability to do markerless body and marker props moving forward is going to be really important.
oh, absolutely.
That's the kind of ideal situation for a lot of stuff.
And so that's something we do offer already in biomechanics.
Okay.
So with like golf and baseball, we track the bat or the club with markers and then track the body with markerless.
Is it two separate systems?
No, so it's the cameras are
All done in
us,
video.
and then the analysis is done with a different program.
Okay.
It's not real time, but it's not a long way off. But so it's definitely something that we already do in other.
For actually longer than really anybody else. I mean, we've been doing markerless motion capture for at least 5-6 years now. But for entertainment, it just hasn't come up as a major moving thing. But that's not to say it won't in the next 2 to 3 years. I know he's got a lot to say about that. So fair enough.
The ability to have people just walk into the vault, like right now, it's just like having people from the audience right now just walk in and try it out.
Yeah.
And there's been situations where performers were just like, well, I would have done it, but I'm not going to put that suit on. But if you want to capture me, I've got an hour. Like, we can do something with that. That does come up, a few time to time. So
Yep.
I think moving forward, that's going to be an interesting.
Yeah, and we're watching that space with a lot of interest. And again, happy to get into that discussion. We don't have a product on the market that we can talk about that has those features yet, but watch this space because we're not divorced from reality at all. But so I think to go quickly back to the calibration solution.
Sorry, I just wanted to look at a couple more things. Can we just walk through the very beginning again? So, so you did like basically like a template of him. How did you bring, can we just bring the skeleton back in one more time?
Oh, sure. I mean, so we can just go back to the original range of motion that we got from him.
Yeah.
Is that all right? Start with that. What happened to my window? There it is. So Will Rom. And no, you're good. This is just over.
Relax. I just want to.
Yeah.
I just want to look
So
at
what
it.
I can do is just.
Actually, quick question to be mindful of Will's time. Do we need Will for more live stuff, Jeff, do you think, or are we good?
No, I think we're done.
I think I'll.
Yeah, if you're.
Look at this. Yeah.
Okay, round of applause for Will, because we got to get him on the road. He's going home to Ohio.
Yep, on the way back to Ohio.
Well, have a good trip.
Yeah. Before we go, can we get a picture together? 'Cause this is a cool suit. So.
Yeah, absolutely.
Make sure you have the flash on.
Yeah, turn the flash on. You light up like a
Oh,
Christmas
make
tree.
it light up? Yeah.
Yeah.
You want to get in?
That's a great stand for sure.
Does the flash go off? I can turn it on. It's kind of weird.
One way or
update.
another.
Awesome. Yeah,
Here,
thank you guys.
You go, take one.
Wind it. I'll get it,
There you go.
boom.
Yeah, four. Here, one more.
One more.
For,
For the book.
there you go.
There it goes. That goes on the wall.
Old school.
Thank you so much.
Yeah,
So
thank you
good.
guys.
Absolutely. Thanks,
I'll
Will.
go. Yeah, I'll go get this.
Yeah, absolutely.
Yeah, thanks, Jeff. Yeah, so just kind of right after the range of motion.
Right, so you'd bring the range of motion in here, so this is the file, and then with the T-pose, the script, there's some built-in marker sets. There's our standard one, which is kind of the bare animation marker set. We like to use an extended version of it, so it's the Qualisys Animation Extended.
Okay.
And then there's a support for like the standard Vicon marker set, you know, if people want to work with that. But then we could just, although we had an issue with his feet, and so the, interesting. Let me try that again. We'll check relabels for some reason. Thought I got rid of that one.
Does it just work on the first frame, or can you scroll anywhere? To do your,
I think oh, I know why he's doing that. Okay. No, you can do it on any frame. Yeah, so you can just scroll
in
to.
case you have a wieldy, unwieldy actor out there.
Yeah, you can.
That's a goofball when you can't
Right.
get
He's
started.
allergic to T-poses.
So, okay, yeah, so this is an interesting thing. When you delete it, you're not actually, so I'm just deleting that one because I know that's a no good nick, but it's still there because all the discarded trajectories still exist.
Hanging out,
Yeah, so you can always get it back. Now, if we do the labeler, there we go. That's behaving better. So it gets the toes there.
So this is based off of like an old, like a person wearing these markers, and it's guessing how it will label.
That's correct.
Okay.
Yeah.
And how do you establish, like, how do you set up, like, is it again in Maya or some other external program?
No, not this part. No, this part is
No,
done.
I know you're doing the identifying, but like when you're saying, you know, you said earlier that to reduce the ability for equipments to flip and so forth, you set up relationships and constraints on how certain segments move together as a marker group.
So that's for the skeleton, not for the label.
Yeah, that's for all the scan. For the labeling stuff, that's just all within QTM, and it's.
So how do you keep things from swapping? You know?
So that part of it is the AIM model. When I create the AIM, which is the labeling tool, the real-time labeling tool, in Post.
It's another TLA. 3-letter acronym. Stands for automatic identification of markers.
Right. The AIM model here, we can show that. I'll show it.
Yeah, thanks. I appreciate it because it's like, you know, he matched a previous actor, so it just works. But it'd be nice to just see.
So the aim is something we use a lot in biomechanics as well, and so it's trained on marker relationships basically. And so if you have a humanoid shape, the relationships are always going to be similar, right? And so if you know I have a marker on the forearm here and I have 2 markers on the wrist here, well, if I lose this forearm marker, if you have trained with the motion that you're going to do, that marker is only ever going to be in this range of motion from these 2, right? And so it labels the whole list based on knowing those relationships. And so, like in biomechanics, we normally tell people, a lot of people do their own marker sets for doing, you know, unique movements and things like that. If you take kind of the 2 bookends of your population and then somebody in the middle, you can train that AIM model. And so you develop it with one person, add somebody on one end of the spectrum, add somebody on the other end of the spectrum, and then you can put that marker set on just about anybody, and the AIM should label pretty reliably because those relationships are defined kind of within that sample set. So the labeling, and that's all that's happening at this point, is there are connections that are being shown, but there's no skeleton being applied. All it's doing is labeling the markers so then you can apply the skeleton based on those labels.
Yeah.
It really does behave quite a bit like the way Cortex did with the template model. It's got to overlap with the definition, but it includes reference frame information. So every 3 markers creates a reference frame. So it knows how the markers, not just the distances, but the orientation. And that's how it helps avoid issues with reflection and symmetry. So what I'm showing here is I'm in the middle of creating the aim for this marker set. And what you're seeing here is not the same as this. This is purely visual. This is actually describing the hierarchy that it found by looking at the ROM and seeing how the markers are moving relative to each other. And basically the only thing you want to avoid is if you don't have enough motion, it might connect markers between the legs and things like that. Otherwise, the way it works its way through the torso and stuff like that, it's most any arrangement works. But you can see it is a hierarchy. And if I don't like it, I can say, well, I don't like that one. I should do something different. So I can click on it until it does something that I like. And so, okay, I like the symmetry of that a little more, so that makes me happy. And so you can adjust that here.
Okay.
And if I call this rule 2. And now if I reprocess the file, so I'll say track it, apply the aim model, will 2, and like so. And then in my display options, I can say something like, for the bones, show the aim structure bones. So I can decide to show the aim bones instead. So you can see what those look like. And these bones are just for you to look at. And so I think part of Derek's question earlier is how to set this up for something new. The way it works is if I remove all the labels and then I go and I do just, instead of the pretty one, I have just the regular one. And this one creates a whole bunch more linkages. And this is the model that it's using to traverse the hierarchy to figure out the relationships between markers. And so some people don't like looking at all this extra linkages, and so I've got versions where you can see them or not. The bone structure is part of the marker set. But if you wanted to create your own model, you'd start with this, add or subtract whatever markers you want, add some linkages, and then in the labeling scripting tool, all you have to do is say create label list. So if I, let's see, let's do this first. So I can say a save label list, and I don't know why it's not giving me my option to make a new folder.
Thanks, Will.
Okay, if I go in there, if I have that label list there, then I can do this thing where it's like create the label list, and it will have saved this definition to that model file. And so now in the future, if you want to identify somebody with that same marker set, you would just use that file to do it.
Okay. Yeah, so then so say we're on set, we got to this point, we're like, all right, all the marks are there. Then how do you bring in the character? Like I saw that you chose the medium one, because that just fits the actor pretty well.
Right, so in that particular case, it didn't really matter which one I chose. Because the idea is that when you fit the metahuman skeleton, you know, if I just go to the top one and do the male short underweight one, the way it works is I've saved every variation, every standard variation of a metahuman, right? They've got 18 of them. So I read it in, and then I look at the positions of the wrists to determine the overall scale factor is not based on height, it's based on width. That's my little secret sauce. And if you look at the skeleton solver for this guy, you can see that it's a 94% match. And so what we'll do is scale the data on the way out such that it'll be, the character will remain the same size. If you change this to 100, you don't change any of the solve here, but when it goes back out, it'll be the same size as the actor. So you have control over what the overall scale looks like on the end result.
Okay, so right now it's globally scaling it to fit the actor?
So it's globally scaling it. So the character stays the same size, right? But if you want props and other things to work and interactions to work, everything needs to be at the same scale. It doesn't have to be 100, but it needs to be at the same scale.
They would both need to be at 94 or whatever, okay.
There you go, right.
Okay.
And this scripting process is available to anybody who wants to try their own custom skeleton stuff. For the most part, I will do it for you. So if you have a model that you're going to be using all the time, kind of a standard model for you, I would write a script that does exactly the same thing for you. Because anybody can do it because the scripts are available, but it does require that you have some proficiency in Python and pretty familiar work. As Alistair was talking about yesterday, you need to be good at doing this to kind of figure out what's going on. Because it's actually, in some sense, fairly simple. What you do is in the script is you have basically two things you need to specify: where all the joint centers are, and then the orientation of every segment. And so the joint centers are defined by markers, and then the orientation is defined by kind of global parameters. You know, I want my body facing this way, I want the arms, the palms facing down, that kind of thing. And so for each particular segment, the logic's actually quite simple. And then once you've described that, then you can just throw it to the class that ingests it. So it just takes it, converts it into something that QTM understands, and that's it. Yeah.
So Jeff, so that the fit of that skeleton in that marker cloud, is that based on is it just doing an auto fitting based on marker positions, or is that something predefined?
Yes, it's doing it's positioning every segment based on rules that it has internally for how to fit to a T-pose. So it has to be, in this case, it has to be a T-pose. So I set the global scale so that the hands and feet match. So there's a scale factor there. Let's see. We dig down into the details here. So in the scripts folder, this is where all of the scripts are located, and you startup is the one you start with. But then if we go to the skeleton menu, is this going to actually show up reasonably? We'll do that. So this is a particularly big file, but so all of these definitions for that menu are right here. And what it does is it says this is an XML file which describes that particular model we've saved out. And then there are these parameters for fitting it. So it knows what the width is, doesn't use the height, where the hips need to be, and some parameters for, like, do I want the arms straight, legs straight, do I want a little bend? Those sorts of things are controllable in this particular script.
So you just adapt it to make it into a Z pose, or absolutely?
Sure, yeah, there's no reason why you couldn't have any pose that you wanted.
And how is this, I guess, taking it into Maya, you said you could bring it into Maya, is that just a visual way to do this?
So this is all Python scripting within QTM. The Maya part comes in for if you want to avoid the scripting part and just one-off make a custom skeleton. And So actually, what I'll do, I can show you that. I can
So
skip
the
to-
answer is you could entirely do it here, but if you wanted, if you were more visually oriented, you could actually do it also in Maya. It's just a lot of folks don't want to get into the scripting because they're not that level of technical artist or.
So, yeah, give me a second to
TD.
fire up Maya, and I can show you an example.
Like I would have to do the Maya path. I'm not a coder.
Yeah,
you know.
For me, yeah, I've never coded a fit into a skeleton. I've always done it visually, so my mind just doesn't work
Yeah.
that way. I would take the jetpack and say, hey Jeff, I have a skeleton. Make this for me.
Well,
Yeah, can you make a button that
we want to
adjusts it?
empower our customers to actually develop their pipelines,
I
and
think
we
if I
want.
did it just visually, if I did it over and over in code, I'd probably get the hang of it and be like, oh, okay, I can figure that out. But just what I've been trained and how I've been doing it, it's been all visual. And
Yeah.
Special Maya plugins.
Jeff.
We have a plugin, a native plugin to Maya. So, and that's on our downloads page on our website, so.
So, to go straight to a crazy example, I mean, this is what the crab character I was talking about that we showed before. So what you do is, these are all just the marker positions, and then any particular joint is got these extra attributes associated with it. So you go through and you specify which DOFs you want, which markers are assigned to it, and what the strength of the markers are for each one. So you can select on any particular segment to indicate, say like for the feet, I increased them to 10 to get the good foot contact as the creature was moving around. And so here you import, you can import a skeleton definition, and then here you would just export it out to an XML file and then read it into QTM with this solver definition.
So do you add or subtract markers from affecting certain zones in this window or in QTM?
It's in this window.
Okay.
Yeah.
Can I see you just add a marker to a zone?
Sure.
Okay, I'll do that.
So for example, let's say I just wanted to, which one is this chin up? Say for example, this one I wanted to add, like, I don't know.
Just add one and then take it off.
Yeah. So let's see, try that one. So there's a little bone icon here that adds it. So if I go look at this segment now, I should have the forefoot out. And then using standard Maya attributes, I can just delete the attribute from there. Where'd my window go? Oh, it doesn't, like the window disappeared on me. There it is. Yeah, I just added one and deleted one right there.
Have you used PeelSolve at all?
I have not.
You should use that.
Yeah.
Because this is what you're doing right now.
It's the exact same idea, the same process for
Yeah.
sure. So we're using OpenSim.
Okay.
Yeah.
But the UI for that does a lot of work.
Yeah. And like PeelSolve, one of the things that we can do here is also attach to rigid bodies and do a globally optimized solve on markers and rigid bodies that are defined in the solve. We don't use that a lot in entertainment yet, but for some physical therapy and other kind of other applications, it's been a useful tool.
Yeah, I mean, you should I can give you the source code for the locators and stuff that I use, so then you can, like, you see the connections and it visually shows it nicely in PeelSolve. It's really straightforward.
Yeah. So yeah, I've been noodling around with some interfaces to try to do that kind of in standalone tools for us, but they're not that great yet. Yeah.
Give me a shout.
Yeah, we'll do.
Can I ask a question?
Yeah.
If I understood, you earlier said that you were working on the...
I'm sorry, the fan is so loud, I can't hear.
IMU?
Yeah.
Uh,
What does that look like?
Well, it is definitely in a working phase as far as like integrating IMUs with the optical.
Is it per marker or is it per drop like the optical has, or how does the whole thing work? If you can fill in that.
I don't actually right now feel comfortable actually revealing more. Like we're driving towards the optical solution with 6DOF. Any integrations of IMUs is on the table because when you get involved with like camera tracking, it goes IMU in there. But we're focusing on the first release is optical. So I mean, maybe behind closed doors we can talk about that in the new year. But today, I think it would be disingenuous of me to. I'd be starting to kind of say things that may or may not be confirmed.
Yeah.
I don't want to lie.
Are you familiar with Excense is also working on?
Yeah. Yeah, absolutely. Absolutely. And that's part of the appeal of IMUs is that you can get some really nice rotational information. And how do we mix all that together? Actually, I think we were talking about that last night, is putting together the optical and the...
Yeah.
Yeah. Noatom was actually doing something like that, and the result was actually quite pleasant, if you didn't mind where the system was set up. But I don't think they do that
Yeah,
anymore.
Noatom did a really good job. They used our cameras for the raw data, and they bypassed QTM directly. They talk to our cameras directly. So we've got IP layers that allow for software to talk to our cameras.
Yeah.
Without going through our code.
Yeah.
That was a cool setup, and then you can, because like, apparently commercial suits stink when you're trying to like climb stairs or go off the ground because you have no ground reference. And so
Yeah.
then you could have that kind of stuff set up within the camera volume, but then you could have a space that's 10 times as big as the camera volume that you interact with, and just make sure that you kind of optimize your setup to do those harder movements in there. And theirs was cool because it brought you back to ground truth when you went to the cameras. And so you could walk around and feel it drift a little bit, and every time you return to the camera volume, you snap back to ground truth. And so you could kind of have a much larger volume and maintain the accuracy. So I think there's a lot of room for something like that to happen again. That worked quite well.
And we've been approached by a couple of systems, suit systems, that also are exploring the problem of how to solve position and banking off of all of the wonderful stuff you get from IMUs, but the kind of like, how do I nail this in coordinate global space? A lot of the challenge is exactly who owns that final product, and that's almost like not a technical problem, but more a commercial issue. You always end up with like, well, then who's selling it, and who benefits from this? And so that's always kind of the challenge. There isn't one manufacturer who does all of it amazing, right? Enough for the kind of level of production you guys are talking about. Maybe for DIYers at home and everything, it's great, but for the kind of level of scope or scale you guys are working at, typically it's not. There's no sufficient solution. Technically, though, it is 100% possible, and Noatom actually demonstrated you can do it. So the door's open for that. We can't comment on anything we're working on that is not publicly known right now.
Yeah.
So.
We did a test with Excense and Vicon.
Yeah.
And this thing, like, especially Excense, because it's actually like approximation of the positions and everything else. Like during a single take, the error between the systems can accumulate to like 30, 40 centimeters.
Yeah.
It's huge. It's like we gave up on that. We were like, okay, this is just not unusable. And then what we discovered about IMU, it was also getting interference from the other devices, like the active devices. So like, if you have something that can cause any kind of magnetic interference, that's actually gonna even get worse.
Well, that's why using those systems on like a enclosed set is kind of fraught with danger. You know, danger Will Robinson. The minute you get into that, like what you're talking about, like a Timberlake shoot, and you're trying to get.
That was Wi-Fi. Like I don't use Wi-Fi on set anymore because that's like the Wi-Fi and Bluetooth is not options for live. Once you get the Teradeks in there, there's no bandwidth left over. Then you're fighting on 2G for everything with everybody else. So then. It's a free-for-all when you turn up on set. You camp out and you get your frequency, and then you like, this is mine, and then the next person comes in and like, oh, I'm gonna have to move my frequency and find an available one.
Yeah.
And there's me with my Asus router trying to compete with like 5 Teradeks, giant transmitters, trying to get Excense.
We run into that at trade shows a lot. Everything worked great in the lab, then we go out to set up our booth and nothing's working. Bluetooth's down, Wi-Fi's down, everything's down. Did we answer all your questions, Christina? Did you have any others? Okay.
Who's your favorite Teenage Mutant Ninja Turtle?
I'm not a turtle fan.
Wow. You just lost all your credibility.
That was after me. It didn't, wasn't on my radar when I was when they came out. So I actually don't know anything about them.
I have a random question. How often, or how many, do you often find some of your partners kind of creating like a hybrid approach of using Qualisys cameras for capture, but maybe they use a different solution for post, like Shogun post, or I don't know if that's something. I know it's a bit of a weird question. I was just curious if that's something.
No. That's a good question. And in fact, yes, we have customers that are doing exactly that. And so that was actually the reason for, I noted that we supported the Vicon marker set, because we have at least one customer that's doing that. They record on our system and then do a lot of processing on their Shogun pipeline.
Is it, for right now, do you mostly have that integration with Vicon? Do you also kind of have other partners for?
That's the only one that anybody's wanted at this point. But if you want, the whole idea is that we can have whatever marker set you want, and all of the processes I've shown can be done with any marker set. And the truth is, there's not much difference between them. There's the labels, it's almost a one-to-one match between markers, except for like on the elbow and the head. It's like, we put the marker in front and they put the marker on the sides. It's like, whatever.
That being said, did they explain why they do that? Why they shoot in one and then do their post in?
Because they have a Vicon system and a pipeline that works for them. And so they wanted to basically get the value from our cameras for their large volume, and then continue to process in the pipeline that they were familiar with.
So they basically get the benefit of the cameras, the raw data, and they push it through. And frankly, we're not averse to any of those situations at all. I would say we're not particular about how our stuff is implemented. Again, not trying to fit you into our box. One of the cool things about how we even just do licensing is we don't put a limit on how many instances of our software you can actually deploy with extra cost. So you buy our software once, you don't have to buy it multiple times. If you need to take homework, or if you need to have multiple locations, we generally don't get into nickel and diming on the software side of things. So we
Yeah, if you're offshoring or bringing in temps or anything like that, it's no extra cost.
So that's a little commercial nugget there. But ultimately, we have a number of companies that love our cameras, love our raw capture, but they've heavily invested in like Shogun Post. They've got a whole team that do it. They've sold a lot of their product based off of that, and frankly, we don't care. Because they're getting out of us what they need, and that's where we occupy our space. Again, leaning on our foundation. Okay, no,
I care a little.
We're not. We're not so precious about play our game and only our game, because we understand that there are systems out there that we have to play with, and so we're not going to start to dictate based off of that.
Are you aware of any instances that are the reverse, where people are shooting in like off-camera cameras but doing all their posts in Qualisys?
I don't know.
No, not in entertainment.
Are we going to talk about the post at all? I didn't memorize the agenda.
Yeah, we can get into like processing and everything, and
I know when.
I think with Alistair and getting into field solve, I think that's probably more the post side of things.
That's good.
yeah.
Okay.
We can definitely discuss that. I mean, we have all the same features you might see in Motive or Shogun. It's the same kind of idea, but I definitely think PeelSolve has a lot to offer there as well.
Yeah, I mean, you're editing marker data, so we have some slightly different approaches to it that have some advantages and disadvantages, but mostly advantages.
Yeah, so we can basically take that and we can walk you through that.
Yeah, we can do that. There's break time, and then we can.
Right. So in about 5 minutes, we're gonna break for some foodage and drink and everything, and then we can kind of get into some stuff over lunch around showing off some wonderful PeelSolve or PeelDev kind of stuff.
Awesome.
And then we'll kind of progress from there. So before we do that, again, have we answered, or are there any questions that are outstanding? Yes.
Camera, someone touches truss, camera gets all decalibrated.
Oh, we never did the calibration, did we?
No, but we should.
We didn't do
we're gonna.
Sorry, I distracted him.
That's all right. That's why we're like again. The agenda was like a suggestion. The agenda is a suggestion. We knew it was going to go off the rails.
It should only take 5 minutes anyway.
Yeah. Well, and the calibration shouldn't take that long either way.
Take less than a minute.
The question is like, is there a world where if that camera gets taken out of the solve, can it try to recalibrate itself to put itself back in during performance? Is there a world that's like that?
Define taken out of the solve.
Because you know how if it's over the threshold limit of not agreeing with the other cameras, it'll take itself off. So when you
It takes it out of like the calculation.
the calculation.
Okay.
If the
Yeah,
residual
it's
camera
not
is too high, it
contributing,
doesn't contribute to the 3D representation.
Yeah. Is there a way to bring it back?
Is there a world, maybe with the advent of AI, that it kind of tries to recalibrate itself and put itself back in?
That's something we've had conversations about. There's not anything currently in the pipeline for it, but I wouldn't say it's completely out of the question.
Yeah. It's a non-zero chance.
Yeah.
Yeah,
I
kind.
think the easiest way, or the most reasonable way to do something like that would be have some sort of references around the room that you can then have input cameras do, right? Of like, hey, you have 2 markers over here, 2 markers over here, 2 markers over here, 2 markers over here, and then use those as reference points, and if the camera starts disagreeing, you can go back to that and kind of do a comparison again. I think with, if all you have in the room is like actors and props, that's gonna be a much harder thing to do, because trying to have a reference point to then get back into calibration with would be difficult, but it's certainly a solvable problem.
It's just we do action design and stunts, and we do like foundation shaking,
Sure.
stuff sometimes, and everything just goes out of whack. So
Yeah.
it's nice once in a while, yeah. You don't have to just.
So all you need
That's
is
why
a
I
truss
made it.
that's held up by drones. so
Yeah.
that you shake the-
What could go wrong?
Well, for camera, we're finding that you necessarily need a wand, and it can be any kind of written object that it can use as some sort of reference point to help triangulate the other.
As long as it is markers a known distance apart. That's, I mean, so I've calibrated with 2 markers stuck on a drone many times in many places. Yeah, as long as it's a known reference distance, that would be all you need.
Okay, that makes sense. Because I know with other systems, when I've done more like post-production work, some, like a camera and the camera triangulate a perfect fit, and then it was moving a little, you just grab that, and let that be like a help.
Sure.
So I wasn't sure if that was like the same for drone.
Yeah, because all we're doing is we're going to the calibration. So we're going to talk about that. We're just defining the distance between the calibration one markers. So as long as you know what that is in millimeters, then yeah, you can put that data in there and then stipulate it that way. And on cue,
Yeah, you took 5 minutes. That took about 3 minutes, so we got 2 minutes to calibrate.
Perfect.
Here we go.
Yeah.
Roll.
Like you mentioned at this point, Field Dev's going to come up with a wand that has a sage attachment so that both you can calibrate and
purge the bad spirits. Yeah.
So we're going to be have a special sage.
And stage the volume.
That's what everybody thinks I'm doing when I do it. They're like, are you blessing the volume? Sure.
That's what we'll call it.
If that helps you, it's magic, it's all magic.
The snake dance.
So do we care about this sitting on over here? 60 seconds like before? Oh, yeah, there we go.
Yeah,
60 seconds as
in
before?
the late 90s, they got rid of the copper bull and the goat.
Go ahead.
We're more humane now.
Sometimes you have to remember. So one thing that's a small departure from the way some other optical systems are calibrated is with our cameras, the intrinsic parameters are dealt with at the factory. So we have a linearization process that the cameras go through with basically a plate with a grid of markers on it. And that takes care of the kind of optical distortion that is within the cameras. So then our calibration process only deals with the extrinsic parameters, so basically the position or orientation of the cameras. And so you only need to calibrate the volume in which you're...
Camera 14, did you get that one?
Oh, yeah. We have this one looking down the hallway, so you just spend a little more time making sure it sees the wall.
It's going to go out the door.
But so basically the more you calibrate, the more likelihood you have for error, because
Oh, there we go.
is going to be kind of a best fit for the area that you're trying to use. And so the benefit to dealing with the intrinsics as a separate process is you can then calibrate for what you're going to be using. And so instead of trying to cover the whole image sensor and trying to deal with those two parameters at once, if you have something where you're only moving in the middle of the room, you can get the best fit for what you're using rather than having to fill the whole space.
And yes, it will bing once you're done with your calibration. And it will bing when you start your calibration if you so choose.
If you so choose.
It's not required. Or can you choose like the sound file?
Yeah, it's a screaming goat.
Or a screaming
I know
goat?
you can with scripting.
Or just like a voice that says, do it! Stop doing
I said
it!
view calibration and then the window didn't come
You're
up.
in the calibration.
Oh, it is in there, okay.
Yeah.
Duh. Okay. So, yeah, so the wanding that the calibration that was just calculated was with the intrinsics from the cameras that were from factory, essentially.
Yeah, so 5 years ago.
You got it.
Yeah.
I'm gonna make sure that's it.
So we can just run it again.
Stop the thing.
So basically that calibration.
You've done a thing.
Around the
Thing.
or all the camera, or like every camera.
That's so funny.
Like, I've seen enough. Like, is that kind of how it works?
So it's more you want to cover the volume that you're going to be capturing with, and assuming your camera layout covers that volume reasonably, you should get enough overlap. But so we're also defining our origin at the same time, and so the origin is defined as basically the point under this L here, and you want as many cameras to see that as possible to use that as kind of the starting reference point. But then as long as you have overlap between cameras that can see the L frame and can see each other, then they can get their positions through that. So like obviously that camera that's pointing down the hallway can't see the L frame at all, but these cameras can see the L frame, and when I'm over here, those cameras can see the one and that camera can see the one, and so it's just simple math.
Yeah, oh, totally.
Extending the calibration.
I'm
Yeah.
just wondering about you physically, what you're doing. You just go around the edge of the volume basically?
Yeah.
And then they're done?
Yeah, I mean, for this, it's a pretty simple volume, but yeah, if we were actually doing a capture today, I probably would have spent a little more time and covered the middle of the room a little better.
Oh, okay.
But yeah, you wanna cover the whole space in which you're gonna be capturing. And so that, one thing we talk about a lot is like, people tend to wand like this, but then you're not doing anything down by the feet. And so, I mean, the cameras are trying to find the best fit for what they were shown. And so, if you don't show them that this is a relevant area, right, the cameras don't know what room they're in, what anything is. They're gonna try to best fit to what information they were given. And so you wanna cover all of the area in which you're going to be seeing markers so that their position can be best fit to that information.
In many cases with like the OptiTrack solution, they've got that, feedback ring and everything. A lot of like what they're doing is the linearization.
We didn't do any
while
groups here, did we?
Calibrating the cameras at the same time.
We didn't do any groups here, did we?
We don't do that
Camera groups?
typically because
Oh, they should be the same as yesterday.
we don't
Oh,
have
did
to
we do the
linearize
camera groups?
cameras.
Yeah, yesterday.
Oh,
at
okay.
the same- It's already happened.
Oh,
Which is
okay.
why our calibration actually takes a lot less time because
talked
that
about
work has
that.
already been done.
Yeah.
So you mean
Extrinsic
it
versus.
takes less time, like, on the computer, like the computer?
It takes less time for you to walk the volume and get all of the appropriate coverage per camera, and it takes less time on the computer to do it because we're not having to recalculate linearization every single time I calibrate. It's already been done. Now you can linearize yourself if you're like, no, I'm going to do mine. You can do that, so we're not taking that away. But typically, especially in this application, that's not something you would need to do.
Unless you're like changing lenses or something.
Unless you're getting in there like exactly and you're changing the distortion quotients per camera lens. We're going to finish this calibration and we'll go.
Well, so the underwater cameras are different cameras.
Yeah, we can put stuff in salt water. That's actually a very interesting point. That's actually an extreme example, but we also manufacture what we call protected cameras. So we have camera housing that is resistant to particulates and
They're
water.
67 rated. So like we have
Yeah.
some like in Santa Barbara that live outside 24/7 for the last 4 years that they use to capture horses. Not
Yeah.
on the underwater treadmill. But
No, I don't want a treadmill. I'm never going to live that down, am I? But that goes everything, not just the camera housing, but also through to the power of the cable, all the other stuff. We have basically just gaskets on everything that goes all the way through. So when we talk about protected, it's not quote unquote protected. It is 100% if not underwater, which is a different camera system, but it's protected. So if you're running live stuff out there on like a set and you're worried about, you know, the flashbangs or the water mist screwing with your mocap cameras, we can actually provide cameras that would not be necessarily with those elements affected by that. You'd have all kinds of issues around, you know, making sure the filters are clean. But.
How do you deal with outdoor mocap?
I mean, the challenge is always interesting around getting the filtering correct. I mean, you've had a lot more experience.
That's another thing that, because we do things like that, we have tools like, so one of the more useful things, not terribly useful in here, but you can see on the upper right side there, we have something called active filtering. And so one of the hardest things with outdoor mocap is the sun. And so what active filtering does is it takes one frame with the strobe on and one frame with the strobe off, and anything that's still lit is just ignored. And so I wish we could like open out the windows or something, because it's one of the most impressive things when you look at just a super noisy volume and you click one checkbox and everything disappears. It makes your life so much easier.
So we have implementations of our systems globally that's outside. And it's one of the big problems we've been asked to solve via that. I mean, it's still a challenge no matter what we do, what anyone does, but we've been employed in multiple instances because we've got that ability to eliminate.
Yeah, we have drone labs at the University of Michigan and at Purdue that
There you go.
outside year-round and are, yeah.
Yeah, and that's the that's where the actual drones are going to be used,
Is Michigan the one
obviously
with the
outside
owl
for a
nested
lot of
on it
these
or something?
implementations. So.
On the Otis camera.
Can you customize the ground plane? Can you be more specific about how would you customize your ground plane?
For example, if it's like a floor stream case where maybe the production volume, you got tons of props in the space and you cannot move, then you got your, let's say, master calibration down with your original ground or frame or
Yeah, the
whatever.
The L frame.
The L frame rather. And let's say you want to create your own custom ground plane where you manually place your own markers maybe on the outskirts, or maybe you want to create much more larger.
It's essentially what we do for the floor calibration.
We did that before you got here.
Yeah, we did that.
The short answer is yes. So we have a couple options. So we do have an option to translate or rotate your origin. And so if you wanted to calibrate here, or maybe the easiest way for you to calibrate is to put the L frame on the wall somewhere.
Exactly,
You
if
still
someone
want.
put markers on the truss, or maybe they want to put like an IR, like something that's more triggable, where they're like, all right, we're just going to enable our ground plane, quote unquote, and shut it off system, and you have to manually come in, place it, and
Yep, yeah. So you can have a translation or rotation of your origin from wherever it was. And then we also do have a floor calibration where you can just put out markers to define your floor if it's not the same kind of orientation as what you're calculating.
It's essentially the same process. Here on this particular screen, you can say, define a rigid body, and then snap my coordinate system to the coordinate system of that rigid body. And so you can make that wherever you want. And that's essentially how the floor calibration is done.
So therefore, no, we're not tied to that piece of metal. We're tied to basically whatever you define as to what it is you want to.
and you're talking, I'm assuming there's like, what they can create like 10 different unique ground planes. And
No, you get 3 and that's it. Stop complaining.
All right, now you're out of questions.
Yeah, pass the flag over, Derek.
So that information is incorporated into the calibration. And so when you, it actually kind of goes back to the earlier question of what to do when something changes in the environment, like a camera gets moved. You can just recalibrate and then later process the move with the better calibration so that you'll get that data with the calibration you did after you captured it. And so oftentimes our users will have multiple calibrations in the day. They'll do one at the end so that if stuff at the end of the day isn't looking good, they can just run it through the different calibration. And so the floor stuff is embedded in the calibration. So you can keep track of that, and there's a folder that we have all of the calibrations in.
I think one other thing worth touching on with setup is camera groupings.
Thank you.
I think that's one of the more impressive things that we have. And so one of the biggest things you struggle with is the cameras are emitting the same light, and so they see each other. And oftentimes the easiest solution for that is putting masks, but then you have a bunch of basically just dead rays through your roof of this camera can see that camera, and so now anytime somebody passes in front of that, we can't see it. So one of the tools we have is called camera groups. And so offsetting their captures very slightly. And so then one
One
group of
pulse.
cameras has the strobe on and it's taking exposure, and the next group of cameras has the strobe on and it's taking exposure. So they're not having their strobes on at the same time, they're not exposing at the same time. And so the downside to that is, because they're not taking captures at the same time, if you're doing really fast motions, you can get some motion blur between those frames. And so if you're doing super high speed motion, you can have a little drawback, but the vast majority of the time, human motion, the delay between the captures is 20 milliseconds. Humans should start moving fast enough for that to be relevant to cause a ton of motion blur. But so actually, if you turn the camera groups off, we can see things get very noisy quickly.
Where's that?
So if you click on cameras, and then exposure delay.
Find the threshold for super high speed.
And then just turn off where it says camera group.
Like a lot of MLB teams have it, the pitchers, like, that's super fast.
So usually with pitching, we don't want to do more than 2 groups, because then each group has additional.
Like an offset.
And so with pitching, usually 2 groups as high as you
But I
want to
mean,
go.
like, 120 frames, 240, stuff like.
Yeah,
So
does
it's-
the frame rate affect that?
It's not necessarily the frame rate, it's the motion, right? So the delay is always the same, regardless of your capture rate. It will eventually, if you have enough groups, limit your capture rate, just because then you start kind of stepping over on the next frame. But yeah, it's more how fast the motion is happening, not the capture rate.
How do you define the group?
So as you can see now, we turn the camera groups off, and all the cameras are seeing each other. It's a very ugly volume, and you have to deal with.
So typically, you just have to mask all that.
Lots of issues. And so the groups are just defined by basically what cameras are looking at each other.
It's offsetting
And so
one pulse.
you have kind of this side of the room on one group, this side of the room on another group.
Yeah, so the idea being like, this would go and that would be off.
Yeah.
Yeah.
This would go and that would be off, so
Yeah.
that right across from each other, you're eliminating having them masked.
Right. But then the benefit is, right, like, if this camera is looking at this camera.
It's still 120, it's just 120 offset.
Anytime a marker passes in the middle here.
Yeah, well, not one frame, one pulse of one frame. Because one frame is 120 frames per second, so. Yeah.
Yeah, so just in this
But if
interface
you
here,
have-
for all the
I
cameras,
would
you
like
just
to
define
make,
which
like,
camera group each one
7
belongs in.
camera groups, because you're going to run into, like, I mean, there's ways to break
Yeah.
this thing up into
And
different
you can also do
ways.
that from the main screen. You can change it.
Yeah,
Right, yeah.
yeah. So that's why we're talking about
You can do that
ultra high speed
here,
stuff.
right?
But typically, people don't.
Set exposure group right there.
And it eliminates a large part of the dead space. Yeah.
Yeah, and then what part of what we did in the setup too is an automatic numbering of the cameras. So we just threw the cameras up on the one long chain and then had it automatically order them. So we started at 1 and just went all the way around. So it's easy to keep track of which one's
we have
which.
masking. You would
There
just
is a
apply
little
masking
number on them,
after
but
the
it's hard to
camera
read.
goes live. Yeah. But no, it's just we,
Oh,
we,
yeah.
do, we do the
How
camera
does that
grouping
work
for the
again?
cameras and then
Here,
masking
and then it's
you have the active.
this guy, right? Yeah.
So we had different,
Well, we have them all on, so if you just like.
Oh, right.
click into one of them.
We do a lot of biomechanics, so
Steph.
like we sometimes calibrate
Bunch.
for like
We can do that.
pitching. We're out on a baseball
Here it is,
diamond,
yeah.
and we put the L frame on the pitching
6,
Probably gonna eat pretty soon.
7.
They're probably eat now.
Oh,
so
yeah, 7.
then it becomes basically your ground plane is set based on that L frame, and so just deciding kind of how you want to define that to best show the data that you're trying to get. So if you have it set on top of the pitching mound, and then the pitcher is stepping down, their feet are going to be beneath the ground plane, and so you likely want to
Yeah,
add
okay.
an offset, but you can do that within our software of adding the offset so it matches the angle, or just dropping it down so it's at the ground level. Basically, the short answer is no, it's not.
I mean, and we work with baseball, Major League Baseball, we work with NBA. We're actually all connected with the NBA, motion capture provider entirely.
Regularly.
Ready?
Yeah, so who's ready to grab a little bite of lunch? Manja? Yeah? So we have food out here. So we're going to break for an hour to refuel and everything. But obviously mingle, talk to each other, talk to us. Let's eat. Thanks, guys. And then after that, we'll come back and we'll get into some Peel Dev stuff, and then we'll do our panel, and then we'll get into, whatever's left over on the agenda. Sound good?